यस, गुड मॉर्निंग स्टूडेंट्स। देखिए आज हम बात करेंगे रिलेटेड टू द यूनिफॉर्म सर्कुलर मोशन। तो ये देखेंगे यूनिफॉर्म सर्कुलर मोशन। देखो यूनिफॉर्म सर्कुलर मोशन क्या होता है? इट इज अ टाइप ऑफ सर्कुलर मोशन। इट इज अ टाइप ऑफ सर्कुलर मोशन in which body moves with constant angular speed. That is, its tangential acceleration is 0. Right? So, in this motion, body transfers equal displacement in equal interval of time. Right? So in this motion, body transfer equal displacement in equal interval of equal angular displacement लिख लो तो ज्यादा सही रहेगा। एंगुलर। देखो यूनिफॉर्म मोशन में क्या होगा? ओमेगा इज कांस्टेंट, मैग्नीट्यूड ऑफ ओमेगा इज कांस्टेंट। If the magnitude of the omega is constant, that is an angular speed magnitude is constant. अगर वो चीज कांस्टेंट है तो we can also say V is R omega. तो V is also constant. अगर V स्पीड कांस्टेंट है, now we can also say ओमेगा अगर कांस्टेंट है तो अल्फा इज d omega by dt, that is 0, and at is R alpha, that is also 0. Right? So both these quantities are 0 if the magnitude of the angular displacement, angular velocity is constant. Yeah, it is not changing, that is constant. Is it right to all of you? So that is the relation for both these things, that is omega and V. Is it clear? So this type of circular motion is called uniform circular motion. So in uniform circular motion, there is only a centripetal acceleration towards center. Is it clear? So this is the relation for it. Right? The next. देखो नेक्स्ट इज कांस्टेंट एंगुलर एक्सेलेरेशन मोशन। देखो इसमें क्या है, इट मीन्स इट इज अ मोशन circular motion in which body travels, your body moves with constant angular acceleration, that is alpha constant. So tangential acceleration magnitude that is 80 also constant. Right? So equation of motions in constant acceleration. Equation of motion. देखो इसमें इक्वेशन ऑफ मोशन क्या बन जाएगी, इक्वेशन ऑफ मोशन विल बिकम, जैसे वहां पर होता था v इज इक्वल टू यू प्लस एटी, वहां होती थी v वेक्टर इज इक्वल टू लीनियर में, यहां बन जाएगी इट इज ओमेगा फाइनल वेक्टर इज इक्वल टू ओमेगा इनिशियल वेक्टर प्लस अल्फा वेक्टर इंटू टी। वहां पर क्या होता था, डिस्प्लेसमेंट एस इज इक्वल टू यू टी प्लस हाफ ए टी स्क्वायर, यहां बन जाएगा एंगुलर डिस्प्लेसमेंट दैट इज ओमेगा इनिशियल इंटू टी प्लस हाफ अल्फा इंटू टी स्क्वायर। वहां क्या होता था, v स्क्वायर इज इक्वल टू यू स्क्वायर प्लस 2as, यहां हो जाएगा ओमेगा फाइनल का स्क्वायर इट इज ओमेगा इनिशियल का स्क्वायर प्लस 2 अल्फा इंटू डेल्टा थीटा। Right? So these are the three equation of motion that you can use in the case of the constant angular acceleration motion. So this is the case for the constant angular acceleration motion, right? Next. So this is the type of the motion that we can discuss that is possible. Now write down the problems related to it. लिखो, a particle is moving in a circular motion of radius small r is equal to 5 centimeter with the speed changes with time as v is equal to 40. Calculate A part. Acceleration, centripetal acceleration at t equal to 1 second. B part, total acceleration at t equal to 1 second. So basically this is the case. So v is equal to 40, the speed is changing with time. So you can calculate the centripetal acceleration. AC is what? V square by R. Now what is V square at t equal to 1? Speed is 4 meter per second. So V square, 4 square is 16 by R, 5 centimeter. 5 centimeter is, it is 5 by 100 meter. That will become 1 by 20. That will come out to be 16 into 20. You just take it as 50 centimeter for the more good appropriate answers. So that will come out to be 1 by 2. That will come out to 32 meter per second square. Now what is 80? dV by dt. What is V? 40. So it will become d by dt of 40. What is d by dt of 40? It is 4. So it is 4 meter per second square. Right? So it is AC and AT. And if we ask to calculate the value of total acceleration A, so what is A? Under root of AC square plus AT square. Now what is AC square? 32 का square plus 4 square is 16. That will become 16 plus this 32 का square. One zero two. One zero 40 second square. Is it clear? So this is our relation for this, right? Next. देखो next. A particle of mass small m is moving in a circle of radius small r such that its centripetal acceleration AC is equal to k square RT square. K square RT square. Then calculate A part, speed of particle, B part, tangential acceleration of particle, C part, resultant acceleration. Now, what is the speed of particle? We have given AC, k square RT square. What is AC? V square by R. So, what is V square? K square R square T square. So, what is V? K RT. It is speed of the particle, which is k RT. First option. Next, पूछा गया tangential acceleration of particle B. Now, what is AT? dV by dt. d by dt of kRT. K is constant, R is also constant. K into R, AT. Now, what is our net acceleration? That is A. That is under root of AC square plus AT square. So, what is AC square? K square RT square का square. And what is AT square? K into R का whole square. Which will become what? K square into R square common आएगा. Inside it will remain 1 plus K square into T square. It is the value of A. एक पार्ट और लिख लो इसका, डी पार्ट, एंगल मेड बाय resultant acceleration with AC. Resultant acceleration AC के साथ कितना एंगल मिलेगा? तो we know, let's put this is 80, this is AC, so this is the net acceleration. This angle is theta. So what is the angle made? It is tan theta. What is tan theta? 80 by AC. We can calculate the value of tan theta, which is 80 by AC. Right, वहाँ से theta भी calculate हो जाएगा, which is theta is tan inverse of 80 by AC. Is it clear? So we can do like this. Is it clear? लिखो इसको. Yes, next question लिखेंगे. Here's next question. The tangential acceleration of particle moving in a circle of radius 2 centimeter, 5 centimeter is 2 meter per second square. If its angular speed increases from 10 radian per second to 20 radian per second during some time, then calculate value of time V bar displacement during this time. देखो, the tangential acceleration of particle moving in a circle of radius 5 centimeter is this. So we have given 80. It is 2 meter per second square. It is constant. Right? If its angular speed increases from 10 radian per second to 20 radian per second during some time, मतलब उसकी angular speed बढ़ रही है, तो 80 is constant. So we can say this thing कि 80 is omega final minus omega initial by time taken. So what is 80? 2. And omega final is 20 radian per second. This is 10. It is 10. So T is how much? 5 second. 5 second is the time taken for this. If it is 5 second, तो angular displacement निकालो इतने में. तो what is the angular displacement? Theta. Angular displacement is omega initial into t plus half alpha into t square. So what is omega initial? 10 into t. What is t? 5. Half alpha. What is alpha? You can calculate the value of alpha. AT is equal to R alpha. Change it here also. We have given 80. We can write alpha is this much. What is alpha? 80 by R. 80 is 2. R is how much? 5 centimeter. 1 by 20 meter. 1 by 20 into 2. 40. That is 40. It is 10. So this will come out to be how much? 1 by 4. Now, what is the value of this? $50 plus half alpha. What is the value of alpha? 40 into t square. T square is 1 by 4 plus square, 1 by 16. That will come out to be how much? 50 plus, that will become 1 by 10. That is 10 divided by, this will 4 into 2 is 8. That is how much? 5 by 4, 200 plus 5. 200 by 4. $50 plus this. This will come out to be 5 by 4. Ready. We will write down one more question. Two satellites are moving in a circular path in a concentric circles in time period T1 and T2. Initially, both are on same side and on line joining. As shown. Calculate minimum time after which both will again on same side. This is the gates in it. Those satellites है which are moving in a concentric circles. ये initially मान लो यहाँ पर है. इट इज मूविंग विद ओमेगा 1 और ये चल रही है मान लो किसी ओमेगा 2, तो हम देखो क्या लिख सकते हैं उससे। ओमेगा 1 जो उसका है इट इज 2 पाई बाई T1 और ओमेगा 2 जो है 2 पाई बाई T2 देख सकते हैं। मान लो ये सैटेलाइट जब घूम के आती है, जब ये मैच करते हैं तो ये कुछ एंगल θ1 घूम के आती है और ये तब तक पूरा कवर करके आ जाती है, मतलब दोबारा भी, और यहीं पहुंच जाती है। अगेन दे आर ऑन द सेम लोकेशन, राइट। तो मैं देखो क्या कह सकता हूं, हियर फॉर मिनिमम टाइम the angle, the difference of angular displacement between both is 2 pi, मतलब θ1 माइनस θ2, जैसे ये तो घूम के गया मान लो θ1, एंड ये वाला जो बड़े वाला है इट रोटेट्स बाय एन एंगल दैट इज θ2. You can take let T dash is equal to time after which both are on same position. तो मैं क्या लिख सकता हूँ, 2 पाई बाई T डैश, एक T डैश से मैं डिवाइड कर रहा हूँ सबको, तो इट विल बिकम ओमेगा 1 ओमेगा 2, बट व्हाट इज ओमेगा 1, 2 पाई बाई T1 और व्हाट इज T डैश, T1 T2 बाई T2 minus T1. Is it clear? So this is the thing for it. Next is the concept that is the relative angular velocity. ओमेगा रिलेटिव, देखो इसको मैं कैसे कैलकुलेट करूंगा, एंड व्हाट इज दिस। सबसे पहले मैं लेता हूं जो सर्कल में हमने डिस्कस कर लिया, मान लो इट इज अ सर्कुलर मोशन, ये सर्कल है एंड वी हैव गिवन लेट्स सपोज मेरे को ये सेंटर है, जिसके बाद वो सर्कुलर मोशन कर रहा है, ये पॉइंट पी है. तो हाउ वी राइट द एंगुलर वेलोसिटी अबाउट पॉइंट एंगुलर वेलोसिटी ऑफ पी विद रिस्पेक्ट टू ओ. दिस इज द लाइन which is joining both the component of the velocity which is along tangential, which is along the perpendicular to line joining O and P, and this is R. तो हम ओमेगा का मैग्नीट्यूड क्या लिखते हैं? That is V square by R. That is the distance between O and P. ये चीज है. हाँ, सिमिलरली हम क्या लिख सकते हैं? देखो, जैसे मान लो हमको लिखना है दीज आर द टू पार्टिकल्स, दिस इज ए, दिस इज डी. इट इज मूविंग लेट्स सपोज इन दिस डायरेक्शन विद V2, इट इज मूविंग इन दिस डायरेक्शन विद V1. So we have to calculate the component of the velocity which is perpendicular to the line joining them. So it is a line joining them. मान लो ये distance L है. Component which is perpendicular to it, its angle is theta 2. तो perpendicular to it is the component which is, पहले तो relative निकालो. तो ओमेगा होगा क्या? Magnitude of omega is component of relative velocity of B perpendicular to line joining both positions divided by distance between them. No, which is the component? ये इधर जा रहा है थीटा 1 से. Let's suppose you will take such type of diagram for to learn it. मान लो हमारे पास ये चीज है. This is the point P, which is moving in this direction with some angle theta 1. And you have to calculate with respect to point A. And A is moving in this direction with V2. And A is moving, let's suppose, in this direction with V2 at an angle theta 2. हमको क्या निकालना है? ये views. It is angular velocity of P with respect to A. तो पहले relative velocity निकालो. Relative velocity निकालने के लिए पलट के देगा अपना. तो ये आएगा This is V2 at an angle theta 2. The component that is perpendicular to it is this component of the velocity. These are perpendicular to it. Right? ये कितना आएगा निकल के? V1 sin theta 1, V perpendicular. It will come out to be V perpendicular divided by line joining. That is distance AP. Now, ये कितना आ रहा है? इस केस में ये कितना आ रहा है? इस केस में ये आ रहा है V2 sin theta 2 plus V1 sin theta 1. Distance, how much is this distance? Let's put the distance given is L. So divide by. This is the angular velocity magnitude of P with respect to A. Is it clear? So in this way we can calculate such thing. Right? लिखो इसको.